For those of you that were away the other lesson, and even for those that were here, I just want to clarify this concept of writing chemical formula and predicting or making ionic compounds. So one of the things we talked about, which was our first rule, was that it must be neutral. So the very first thing we need to talk about is that the result itself, so what's made, that which is the ionic compound itself, it must be neutral. And what we mean by this is that the combination of the two ions has to be cancelled out. So for example, we would say that if we had an Na plus and I add that to a Cl minus, here I have one plus. So I've got a plus and I've got a minus. These are going to cancel each other out, and when I put them together, I just get NaCl. And I could keep the charge and say Na plus Cl, but the total ionic charge of the entire thing is 0 because the plus cancels out with the minus. So that thing would be charged. However, if I then did something different and I had like Mg, which is 2 plus, and I add that to chlorine, which is a minus, I've now got, when I look at my individual charges for the ions here, I've got a 2 positive charge and a 1 negative charge. So if I put these together and write my Mg 2 plus Cl minus, the overall charge of this whole thing is actually no longer 0 because I've got plus 2 and minus 1. And these do not cancel. I end up with a total charge here of plus 1. So in order to fix that, I need another negative charge. And I can't just write 2 minus here because Cl is always minus. So that's not something I can change. But because I'm writing a compound, I can use a subscript and say, well, that must be 2 lots of Cl. So magnesium chloride, which is what this thing would be MgCl2. And now I've got 2 lots of minus and 2 lots of plus. The overall compound is neutral, and that's what we want. So this is the concept there. If I was to look at a random example, so something from the task sheet, let's say we take calcium and I'm going to do iodide. One of the rules here is that the anion here, which is the non-metal, always or nearly always becomes an ide. So if you look at the pattern here, we had chlorine became a chloride, oxygen became an oxide, iodine became an iodide, hydrogen to hydride, sulfur to sulfide, nitrogen to nitride. So the anions or the non-metals become the ides. The metals retain their name. So we always name it after the metal first. So for example, sodium chloride, potassium oxide, magnesium iodide, and so on. So if we take a random example, let's go calcium iodide. That's right here. We don't know what this is going to be yet. And even calcium, when we look at the periodic table, calcium is, where are you? Calcium, 20. So in this version of periodic table, it gives you its configuration. It's 2882. You could see it up on the top right of the screen in the big square. But in a test and things like that, you are not going to be given a virtual periodic table. It's not just going to tell you the configuration. But you can cheat. Rather than try and figure out what is the configuration of 20, or if we go further down when we see things like zinc and copper and stuff like that, that's beyond the configuration that we're expected to know. But we can cheat. So we can use what we know about the periods, which are these vertical rows. So if you look at the box here for the electronic configuration, look at how many electrons it has in the outer shell for beryllium, magnesium, calcium, strontium, barium, and radium. Notice they all have a 2. That's because they are in period, which is the vertical, 2. So that tells us it has 2 electrons in the outer shell. So it doesn't matter what number it is. I can just cheat and say for any element, say I did something crazy like silver or aluminium, I can just find it. Silver is a weird one. Silver is Ag. So that's a pretty horrible one. In this case, it's 2, 8, 18, 18, 1. We're not expected to know that, but again, we can use this concept of its period. It is period 11. We ignore the first digit. The second digit is 1, so it has 1 in its outer shell. So it's going to lose 1, and therefore it's going to become a +1 charge. if I went to something like aluminium, which is here, it's 13, and you might forget, oh, what's the configuration again? But it doesn't matter, it's in period 13. So we ignore the first number, it has 3 in its outer shell, so therefore it's going to lose those 3 to fill up its second shell, it's going to become a +3. So if we take an aluminium case, aluminium chloride would be, aluminium, remember we said was Al3+, and that's purely from looking at the periodic table where we had aluminium, it has 3 in its outer shell, it's going to lose those to fill up this shell, so it's going to become +3. And chlorine, if we look up the chlorine element, it is Cl here. It's in 17, so it has 7 in the outer shell. So it has 2, 8, 7. It wants 8 to be stable, so it's going to gain 1. If it gains 1 negative, it becomes negative. So we've got Al3+, Cl1-. If we put these two together, AlCl, we've got 3+, 1-. This is currently not neutrally charged because we've got 3+ and 1-. The resultant here is a 2+. However, if I add 3 more chlorines down here, or have 3 of them, I've now got 3 lots of negative, 3 lots of positive. This thing cancels out. It's neutrally charged. So the formula for aluminium chloride is AlCl3. So that is the ionic compound. So the idea is that you make sure it's neutral. We start with step 1, recognize what each ion becomes for the combinations. Step 2, look at the total ionic charge. So add the two numbers together, the pluses and the minuses. Step 3, add a little subscript to whichever one you need to in order to cancel out the charges. And that's it. As I mentioned in the lesson, if you come across an instance where you have something like Al3+ and like Na+, for example, this is a plus, this is a plus. There is no subscripts that we can use here that are going to neutralize this thing out. So it tells us something very important. It tells us firstly that there is no existing compound as aluminium sodium or whatever you would call that. It's not a thing. It also tells you that these two would not react. You cannot mix these two together and get an Al-Na compound without adding other stuff. And that's because these are two metals. You can't just put aluminium and sodium together, just stick two metals next to each other and they suddenly create a new product. That's not what happens. So we can also use this information to tell what is even going to be made, if anything is going to be made from a reaction.